Thanks for joining us for today's Flashcast webinar. Today we'll be discussing how Pure Storage and Delphix have teamed to supercharge database deployments. We've got a special guest, Kyle Haley from Delphix, along with Pure Storage Database Solutions Architect, Chaz Dye. Gentlemen, take it away.
Thank you, Katie.
Hi, I'm Kyle Haley. I'm the technical evangelist at Delphix. I'm also an Oracle ACE and member of the Oak Table Network.
Hello, I'm Chaz Dye. I'm the Database Solutions Architect at Pure Storage. I've been in Oracle DBA since version 5, and I'm the author of multiple O'Reilly books.
So a little bit about Delphix. Delphix was founded in 2008, and we launched our product in 2010. The CEO is Jed Yue. He's also the founder of Avamar, which is over $1 billion revenue company that he sold to EMC. Delphix is based in Silicon Valley. We have global operations and are used by 10% of the Fortune 500.
Pure Storage was founded in 2009. We make an all-flash enterprise storage array. We have a team of over 300 people, mainly storage industry veterans. We have $245 million in backing, and we have 30 patents in process. The Pure Storage array has 4 main features. First is, of course, high performance, as you would expect with a flash array. Along with high performance, we have inline data reduction. That means deduplication and compression, and our data is always encrypted at rest. In addition, as you would expect from a enterprise-level storage array, the Pure Storage array is highly resilient and scalable. In addition, we value simplicity. So all you need to do, for example, to create a LUN is know how large you want it to be and what its name is. And lastly, we use 100% MLC flash to keep the cost of the flash array down to a minimum. As far as the hardware specs, the performance capabilities of this array are 400,000 IOPS sustained I/O, 200,000 write IOPS, and less than a millisecond of latency. We have 5.5 terabytes per shelf, and we scale up to 33 terabytes. We use either fiber channel or iSCSI connectivity, and we have an HA as well as non-HA configuration.
And here you might be familiar with the cycle that we've seen in the industry. This is where IT department budgets are being constrained due to budget concerns. And when IT budgets are constrained, one of the first targets is reducing storage. And as storage budgets are reduced, the ability to create database copies and provision development environments goes down. As development environments become constrained, the projects that depend on those environments start to hit delays. And as the projects are delayed, the applications that the business depends on to generate revenue to pay for IT budgets are delayed, which reduces revenue as the business cannot access a new application, which in turn puts more pressure on IT budget, and thus it becomes a vicious cycle. And talking to customers in the industry, some of the things that we have found that are causing delays in development costs are inefficient QA. And this is where it takes a long time to build a QA environment. So if I want to QA some code, the actual cycle time for that QA, we might spend 90% or more time building the environment and only, say, 5% actually running the QA suite. And the second thing we see is QA delays. Because it takes a long time to get code QA'd, there's more time after a bug is introduced in the code before it's found. Thus, there's dependent code that's written, so it causes greater rework of the code. The third thing we found is where development environments are being shared by developers, and this causes bottlenecks. So one of the companies that we talked to, eBay, they have a team that's sharing one single copy of a production database, and if a developer wants to make a change in the schema or the metadata or change some data in the tables, it's a 1 to 2 week code review process. I don't know about you, but that really killed my motivation as a developer. The fourth thing that we see is where development teams, because of the requirements, the resource requirements to create a full-size database are so enormous, companies are going to subsets of the database. So each developer can get a small subset copy of the database and do their coding there. And while this parallelizes coding and parallelizes QA, when this code actually hits the production environment with a full set of production code, we often find that the code runs into bugs and hits the wall. Classic cases where the code runs fast on a small set of data, but it runs slow when it hits the full data sizes. And the fifth thing we see is, and the most pervasive thing we see, is slow environment build, where development teams request environments and it takes maybe weeks to months to actually get those environments. So what happens when somebody requests an environment? If I'm a developer and I want to get a copy of the database to do some coding on, I can submit a request to my manager. My manager has to decide whether to approve it or not. If he approves it, it would go to a DBA, who has to contact the system admin. The system admin has to contact the storage admin, make sure there's storage. If there's not enough storage, then storage has to be ordered. One large global bank we talked to, their typical creation time for a copy of a database is 3 to 6 months. In a recent CIO magazine survey, over 60% of projects in the industry right now are over budget or over schedule. And of those projects, 85% of those are running into those delays because of provisioning time for development environments and copies of databases. So data is the problem. The problem is getting the right data to the right people at the right time. But this problem can be solved today. With Delphix, we can unlock your data. So for making copies of a database for different teams, such as development, QA, reporting, across all those clone copies of the database, 99% of those blocks are going to be identical, and only a small fraction of it's going to be changed by each of those groups or people. So what about going about it in a different way? What if we could actually share those duplicate blocks across all those clones? And if a clone or a copy made a change to a data block, what if we could keep that change block private to the clone? So this is what we do with Delphix. So on the left here, where we have the classic copying of a database, the target machines running the database instances are connected to a SAN. Each of those copies has a full set of data files. We can change that on the right in a virtualization world, where I take 3 virtualized copies of the same database. They come into Delphix. Delphix looks like a NAS, and it orchestrates access to a backend array where there's a single set of data files. It's not just a single set of data files, but these data files represent the data at different points in time, so I can have clones at different points in time. And we also orchestrate access to who sees which changed data, and we keep data that's modified private to the clone that made that copy. So what is Delphix? Delphix is just software. It fits on a USB stick. It installs on any commodity Intel hardware. And we can assign any storage to it. It could be EMC, NetApp, Fujitsu. And one of the most exciting things is, because we can use any storage, we can use the new flash arrays from Pure Storage. So once I've installed Delphix and once I've assigned storage to it, at this moment I can link to a source database. At linking time, we take an initial copy of that database. We take this full copy once and only once. And this technology is supported currently on SQL Server and Oracle, and upcoming will be Postgres, Sybase, and MySQL. After we take that initial copy, which is compressed typically by 1/3, we then collect incrementally and forever changes from the source database. And we keep those changes in a time window. By default, the time window is 2 weeks, which means I can spin up a clone anywhere from within that 2-week time period, creating a copy of the database at different points in time. So before virtualization, a typical architecture would be a production database where we've made full copies for different groups, such as development, QA, and UAT. But in the virtualization world, we take one copy of that production database, link it into Delphix, compress it, and then all the different teams share that single copy of the source database. And the interface is a simple, clean GUI. And I, as somebody who loves graphics, I worked in the enterprise manager group at Oracle. I got a kick out of it when one of our customers said, Delphix graphic interface looks like what OEM would be had Apple created it. So there's, just to give a little bit more background on what's going on here, there's 3 core parts to database virtualization. On the left, the first part is how do we get the source database into the virtualization tier? So we have to have some sort of copy technology. And not just copy technology, but how do we keep pulling in changes from that source database so we can keep cloning the source databases as it changes over time? The second part is the cloning technology. There has to be some sort of file system snapshotting technology that can snapshot the file system at different points in time and then clone from those different snapshots. And on this cloning technology, what we want is storage agnostic, so it can take advantage of new flash technology. And one of the cool things is not only do we share the storage on disk, but we also share it in memory, our cache on the Delphix platform. And the third part is provisioning. Once I have these snapshots, how do I create actual clones? So I have to be able to mount those file systems. I have to be able to start up an instance, recover the instance, rename the instance. And then what about allowing self-service? If I want developers to have access to this, we want to have self-service, we want to have roles and security, and this is what Delphix provides. And on top of that, provides functionality such as rollback and refresh, so a developer can refresh their database or roll it back, and branching and tagging, so that we can treat data as we do source code, or we have source control versioning, we can have data versioning. So what this provides us with is fast, full, fresh copies of the database. Creating a clone with Delphix takes just a few minutes, and thus it can be just a few minutes behind the source database, and for all intents and purposes, these databases are full copies. And this allows us to give as many copies as we want. So one of our customers, StubHub, which is part of eBay, they went from 5 copies of their database to 120. They gave out 1 to each of the developers. So what we've seen with Delphix, being able to virtualize virtualized databases allows efficient QA. It allows, instead of spending 90% of our time building QA environments, we can spend, say, less than 1% of the time building the environment and 99% of the time actually running the QA suite itself. Because building QA environments is quick, we can QA bugs immediately after the end of a sprint or code freeze. Because we can create as many as we want, we can give every developer their own copy of the database, thus parallelizing development. These are full copies of the database, so we see less bugs that end up in production, and we see fast build times. So this creates a culture of yes, where currently developers might not be even asking for what they want because they know they can get it. Now they can get what they want, so we see a lot more productivity. So here we teamed up with Pure Storage and Delphix to show the power of combining the two together. So on the benchmark, what we took was a benchmark tool called SwingBench. This is produced by a fellow from Oracle at Oracle UK. It's pretty well known, has multiple benchmarks possible within it. The workload we chose was sales order entry, which is a TPCC-like benchmark, so it runs OLTP workload. We created a 1 terabyte dataset size for this benchmark. And then what we wanted to do is compare running this benchmark on standard spinning disk with virtualizing the databases with Delphix using Pure Storage. So on the first test, what we took was 15 disks at 15K RPM, ran the benchmark on it. The machine that was hosting the instance had 512 gigabytes of RAM. The SGA was 8 gigabytes, and of that we gave 4 gigabytes to the buffer cache. And then we ran this at full tilt with SwingBench. The maximum TPN we could get was 35,000, and this was 2,500 IOPS. IOPS were basically the limiter in this benchmark. Then what we did is we're going to try the same benchmark but using Delphix and Pure Storage. So we loaded up the data into Delphix, where Delphix is using Pure Storage for its storage. And then we created 26 copies of the database. So we did 26 copies just like the spinning disk case. And each of these databases was running at over 35,000 transactions per minute. And so the total aggregate across all these 26 copies was over 900,000 TPM. And what this gives us, which is pretty amazing, this gives us for the total cost of Pure Storage plus Delphix was 1/10 of what it would cost to create 26 physically spinning databases at the same TPMs. So this gave us 900,000 transactions per minute, and the space used by combining Delphix with Pure Storage is 1/25 the space that it would take to run these same databases on spinning disks.
And besides that, we were nowhere near hitting the top of the capacity of the Pure Storage array. So there's plenty of headroom not only in terms of capacity, but also in terms of performance for adding other databases, applications, or whatever else you want to use the storage for on our Pure Storage flash array. That concludes our webinar. Now, do we have any questions from the audience?
We have had a few questions come in during the presentation. The first is, why was it 1/10 of the cost? where does this data come from?
Well, it was 1/10 of the cost because if you consider the IOPS necessary to drive that benchmark on spinning disk, you're going to need like 2 or 3 complete racks of spinning disk in order to provide that same throughput and the same IOPS capability.
Okay, thank you. Let's see. If I deploy this combination in my own environment, will I see the same results?
It depends on what your workload is like, but the opportunity that we tackled here was the OLTP because we typically see more OLTP workloads. But OLTP tends to be CPU bound. And actually in the test, one question that's come up before when we've talked about this is why did we stop at 26 copies of the database? The reason we did is we maxed out the CPU on the 2 ESX boxes we were using. So if we go to a more I/O-bound benchmark, say like a data warehouse benchmark that's truly I/O-bound, we stand to see even greater performance improvements.
All right, it looks like you may have answered this follow-up question that came in during your response, but what about database house? Will I see similar results?
Oh, and the warehouses. Yeah. So yeah, like I was just saying, the workload that we ran was OLTP, and it's less I/O dependent. It's definitely I/O dependent, but it's more CPU bound than I/O. So if we change the workload to actually something that's very constrained on I/O, potentially see much better improvements. And also to sort of follow on to these two questions is we've actually proven this in the field. We've worked with Coherent, who's used the combination of Delphix and Pure Storage and is very happy with the results.
Good to hear. So we've had a couple more questions come in. The first one, what is the hit on the production database when you deploy?
Yeah, that's a good question. A lot of our customers worry about what's the impact on the production database. With Delphix, it's basically almost no impact. We use RMAN APIs to get the data. The biggest impact would be when we first link, we have to get a full copy, but customers typically take copies once a week anyway, so this is nothing new. And if there's any concern at all, people can hook Delphix up to a standby database, for example. So really there's no impact on production.
Okay, we've had a follow-up question come in on that one. What about ongoing?
Ongoing, when we say ongoing, the thing that comes to mind is what about the changes that come into production? So after that initial copy that we only do once, well, what happens? Well, Delphix keeps pulling in the changes and storing the changes, and we do that with 2 methods. One, we pull in the redo logs as they're created, which is optional, and the other way, which is not optional, is taking snapshots. So we use RMAN backups from SCN. So it takes just the change blocks, and that requires block change tracking from Oracle to do efficiently. And with block change tracking, it's quite efficient. And people worry about, well, what's the storage impact of this? I'll just give you an example. So what if your source database was 9 terabytes? It comes into Delphix and Pure Storage. It's going to be compressed down typically 1/3. So that'll turn into 3 terabytes. Now, how much change can we store? Well, in order to get to the size of the original database, which was 9, and I've stored 3 on Pure Storage and Delphix, that leaves 6 terabytes of headroom before we even hit the original database size. Well, that's not 6 terabytes. That's actually 18 because it's going to be compressed. So we can pull in 18 terabytes of changes from the source before we even hit the original size of the source database.
Great. Here's a good one. The cost reduction is great, but how do I move my dev test and QA to Pure?
So again, it's pretty simple. Delphix is all about simplicity and agility and ease of use. If we have dev, test, and QA as copies of a source database, then all we want to do is you want to link Delphix to the source database, which is just filling out a few fields, some connection information, and then Delphix will take care of it automatically. Just to reiterate, when we first link, we take a full copy once and only, never again, and from then on out, we pull in the changes at a frequency that you set. Typically, it's 1 snapshot per day, and then we pull in redo logs as they're created optionally if you want.
All right, let's take one final question. How does this compare to Oracle pluggable databases?
That's an awesome question. Actually, it's one of the things I'm excited about. So Oracle has now in 12c pluggable databases, and what's cool about pluggable databases? Well, they take practically no memory. So if I have a Unix machine running a bunch of instances of Oracle, at a minimum, they all take up about a half a gigabyte of memory. So I'm limited to how many instances I can start up. I'll just give you an example. In this particular benchmark that we ran, the Oracle databases all had about a gigabyte of memory. So that limits how many databases we could do. Well, with pluggable databases, all those requirements basically go out the window. It's like probably less than 100 megabytes per instance. So that's awesome. I've got this machine. I can load it up with a couple of hundred databases. Great. Well, what about the disk space? This is where the match comes in. If we marry Oracle 12c pluggable databases with Delphix and Pure Storage, not only do we have those memory savings, we have the disk savings. And also not only disk savings, but time savings. I can spin up these clones in a couple of minutes no matter what size they are. They could be 50 terabytes. I can spin them up in a few minutes. Doesn't take hardly any extra disk space and doesn't take up hardly any memory with the pluggable databases.
Fantastic. Thanks again, gentlemen. And audience, we hope to see you on our next webinar.
All right, thank you.